That is so embarrassing. Oh my gosh. Do not start to parent. It's too much. Just kidding. I'm so sorry. Back to my problem. Okay, so this is you. Hopefully you still tune in for this one, because I know when you have to go to the second video, you're like, I'm not doing that. Okay, don't forget you also have to find du. So I end up with a 2 dx. I don't have that. I'm going to stick a 2 in and a 1/2. So now I've got all of my components. I'm going to have 1/2 times the integral of du over the square root a squared minus u squared. Hopefully I skipped a step there, and hopefully that makes sense. I know that this is a, I know that this is u, and I know that I needed a 2 and a 1/2. So here we go. 1/2, I'm going to go to my formula, arc sine of u over a plus c. Yes, I can reduce them. 1/2 arc sine of x plus c. That's crazy, isn't it? So go back and do the derivative of that. Go and check. So if I check, the derivative of this is 1/2 times 1 over square root of 1 minus x squared. And you might think, well, how is that the same as this? I don't think this is something I ever really went over until I started teaching, but like, how would you get this 2 to go back inside? You know, this 2's out. He's like so happy he's out of his shell. But what if we have to shove the 2 back in? What do we do? Well, then it would be like, this is the same thing as like 1 over the square root of 4 times 1 over the square root of 1 minus x squared, right? 2 is the same thing as the square root of 4. That's how we get that to shove back in 4 minus 4x squared. So yes, I do have what I originally started with. Okay, hang in there. We only have one more, and I know the first video was probably 20 minutes, and now this one's going for a while. I know, I get it. I'm sorry. If it helps, I love you. But are you going to love this problem? Oh my gosh, it's so funny. It's so hard. Okay, again, if you tried substitution, it ain't gonna work. First of all, if u is e to the 2x minus 1, du is gonna be e to the 2x times 2. Where is that? It doesn't even, there's not even other e's in here. Like, what? So this looks a lot like, oh crap, it looks like arcsecant actually, doesn't it? That's so disgusting. Let me look at that formula again, because it's not arc sine. Notice the difference in the order here. The constant isn't first, the variable's first. So this is probably going to be an arcsecant. Sorry about that, but whatever. The idea is still going to go the same. So arcsecant, if you hear my notebook flipping, it's because I always have to go back and look up this one. Wait a second. Maybe I don't think I copied the problem down wrong. I mean, I don't think I copied the problem down right. Oh my goodness. See, if we were in class, I could tell a little story while I look up the problem again. I don't really have any stories. Other than Beyonce has a new clothing line out. Did you know that? If you didn't, shame. Shame on you. I'm really sorry. Fast forward for a second. I'm just looking up the problem because I don't want to go through it if it's not right. Inverse trig. Here it is. I took the problem from our textbook. Oh, right. Haha. This needed a crazy thing. Okay. I think I got it. I think the problem stays how it is. Okay. Sorry about that. Okay, so I know you're like, if you don't know what you're doing, how the heck am I going to know what I'm doing? It's a good point. You make a valid point, but we're still going to do it anyway. So secant is going to be 1 over a arcsecant, absolute value of u over a plus c. Okay, so we need our u and we need our